Everybody has a genome and an epigenome. The first refers to the DNA that makes you who you are. The second, epigenetics, is the expression of those genes, which of them get turned on and off. Professor Trey Eidecker says you can think of genes and their expression as being hardware and software.
Some people in the field have likened damage to DNA as damage to hardware in a computer, the primary circuit board.
In this analogy, the computer software is the gene expression, which tell DNA whether to form a heart cell or a lung cell, or, over time, to show signs of aging if that software doesn't get an update. Changing patterns of gene expression, what scientists call the epigenetic clock, are strong indicators of one's biological health. And a hot topic in science today is the question of what causes aging. Is it damage caused by gene mutation or gene expression? And the most promising answer to this debate might be to say that it's caused by gene expression, a somewhat predictable process that can be reversed. But Eidecker, who helped discover the epigenetic clock about 10 years ago, says that might not be the right answer.
I think there's a lot of investment recently in this idea that reversing the epigenetic landscape is going to slow or maybe even reverse human aging.
He says a new study he oversaw doesn't eliminate that possibility, but
it certainly casts a cautionary note that we should also look at the primary causes of some of those changes, which are likely to be in the DNA itself.
The new study was published in the journal Nature, and it shows that gene mutations may be the true cause of aging. Eidecker compares gene mutations to lightning strikes that are powerful and unpredictable. If mutations are the true cause and epigenetic changes simply reflect them, then coming up with treatments for age-related conditions could be much more challenging. What's at stake is not necessarily the length of time people live, but their quality of life.
Many of us think about growing older, and the thing we perhaps fear most isn't dying, but losing the ability to live the lives we want to live.
Zane Koch, the lead author of the Nature study, says the new research has not disproved the predictive value of gene expression.
Now we're kind of looking back at why those epigenetic clocks tick, and it appears that it might be through changes to our DNA in the form of mutations.
Researchers say conclusive proof of their theory will require more research aimed at better understanding gene mutations. Thomas Fudge, KPBS News.